Section 4.2 is on factors and simplest form. The goal by the end of this section is to be able to simplify any fractions and put it in simplest form. Okay, so let's go through this. In order to put fractions into simplest form, the first thing we have to understand is what factors are. So a factor is a number that divides another number perfectly. So with the number 63, 7 and 9 are factors of 63 because they go into 63 perfectly. 3 is also a factor because it goes in perfectly. 21 is a factor. So a factor is a number that goes into another number evenly or perfectly with no remainder. Okay, that brings us to two types of numbers. There's prime numbers and composite numbers. A prime number is only divisible, or its only factors are 1 in itself. So the only number that goes into 2 is 1 and 2. The only number that goes into 3 is 1 and 3. The only number that goes into 13 is 1 and 13. That's what a prime number means. The only numbers that go into them are 1 in itself. A composite number has more factors than just 1 in itself. So for example, 6 is a composite number because 1, 2, 3, and 6 all go into it. It's not just 1 in itself. 9 is a composite number because 1 and 9 go into it, but also 3. So there's two types of number, prime numbers and composite numbers. Okay, so is 16 prime or composite? 16 is composite because it has more than just 1 in itself as factors. 2, 4, and 8 all go into 16. How about 31? 31 is prime because nothing goes into it besides 1 and 31. How about 49? 1 and 49 go into 49, but also 7. So it is composite because it has more than just 1 in itself as its factors. Okay, that leads us to prime factorization. A prime factorization breaks a number, a composite number, down into a product of its prime numbers. Product meaning multiplication. Okay? To find a prime factorization, we use what's called a factor tree. Perhaps you remember doing factor trees. Okay, so let's get your handout for this section out. The first one says, find the prime factorization of 30. Okay, so to do that, we start with 30, and we start with our tree. So what are some numbers that go into 30? 3 and 10, 2 and 15 would both work. You can use either one, you'll get the same answer. You could also use 6 and 5. Okay, 6 and 5. Okay, 5 is prime, so we can either circle that, which is what a lot of students do. But 6 is not prime. That can be broken down into 2 times 3. So 30, the prime factorization of 30, is 2 times 3 times 5, and we usually put them in that order, the smallest to largest. 2 times 3 times 5 gives you 30 if you multiply it out, and those are all prime numbers. It's called the prime factorization. Okay, how about 36, letter B on your handout? Okay, 36 can be broken into multiple different things. 6 times 6, 3 times 12. In this case, 9 times 4 would work also. Any of those would get you the same answer. Neither 9 and 4 are prime, so break those down again. 9 breaks down into 3 times 3, and 2 breaks down into 2 times 2. So the prime factorization of 36 is 3 times 3 times 2 times 2. And normally, again, we put that 2 times 2 times 3 times 3. If you have repeated prime factors, remember you can write them with exponents. 3 squared times 2 squared, or 2 squared times 3 squared. Alright, so why don't you try to do letter C on your handout? For class, write the prime factorization of 72. So go ahead and pause the video and do that now. What do you do when you get to harder numbers? Like letter D says 297. What if you're not sure what goes into 297, if there is even anything? Okay, so to do that, there's some divisibility rules, or a divisibility test that helps us with this. So how to figure out if 2 divides a number is if 2 only goes into even numbers. Okay, so if the number ends in 0, 2, 4, or 6, or 8, then we know 2 divides the number. To figure out if 3 goes into a number, you find the sum of the digits and see if that is divisible by 3. The sum of the digits, remember sum means add, means you add up the 3 digits. So to see if 3 goes into 144, 1 plus 4 gives you 9, and 3 goes into 9, so therefore 3 has to go into 144 perfectly. Another one is 5. To figure out if 5 goes into a number, the last digit of the number is 0 or 5. There's a couple not listed here. To figure out if a number is divisible by 10, it has to end in 0. To figure out if a number is divisible by 9, it's the same rule as number 3, if the sum of the digits are divisible by 9. So for 144, 1 plus 4 is 9, so 9 would also go into 144. If we have 1,105, or 1,115, 1 plus 1 is 3, plus 5 is 8. So 9 would not go into here because 9 does not go into 8. 3 also would not go into here because 3 does not go into 8. So those are some divisibility tests to help you figure out what goes into numbers like 297. So 297 ends in 7. So we know that 2 does not go into it because it's not even. If you add 2 plus 9, you get 11. Plus 7 gives you 18. 3 goes into 18. Therefore, 3 would go into 297. 9 also goes into 18. So therefore, we know 9 would go into 297. So you can use either one. I use 9. 9 times 33. If you did it out. 9 can be broken down into 3 times 3. And 33 is 3 times 11. So that gives us the prime factorization is 3 times 3 times 3 times 11. Or 3 cubed times 11. Okay, why don't you use your divisibility test to try letter E? Find the prime factorization of 252. Alright, now that we understand prime factorization and factors, now we can begin to write fractions in simplest form. Okay? What simplest form means is it means that neither the numerator and denominator have a common factor. Nothing goes into both of them. Okay? A fraction is written in simplest form or lowest term when the numerator and denominator have no common factors besides 1. So some examples. 10 over 42. 10 over 42 is not in simplest form because something goes into both 10 and 42. And that number is 2. So you can rewrite these as factors of 2. 10 is 5 times 2, and 42 is 21 times 2. So now what you can do is you can reduce the 2's away because 2 goes into both, and that reduces to 5 over 21. So 10 over 42 is the same thing as 5 over 21, it's just reduced. Similarly, 9 over 27 can be reduced because 3 goes into both, but also 9 goes into both. Again, you want to use the largest, or you can write it out separately. 9 is 3 times 3. 27 is 3 times 3 times 3. Okay, the 3's reduce. 3 and 3 reduce, 3 and 3 reduce, and you're left with 1/3. Now you don't have to write all this stuff out in between if you're familiar with this. You can just write 10 over 42. Think about it. 2 goes into both. 10 divided by 2 is 5. 42 divided by 2 is 21. Same thing here. 9 goes into 9 once. 9 goes into 27 3 times. So you don't have to write all this stuff in between, but that's how it's being explained. Letter C is not on your sheet. 8 over 36. What goes into both 8 and 36? 2 maybe? 4 maybe? I think 4 goes into both. So 4 goes into 8 twice. 4 goes into 36 9 times. So that would reduce to 2 over 9. I'm not sure if I said that right. 4 goes into 8 twice. 4 goes into 36 9 times. So it reduces to 2 over 9. 2/9 is the same thing as 8 over 36. Alright, so why don't you try letter C on your sheet here. Reduce 30 over 45. To do that, try to find the largest thing, the largest factor that goes into both. If you don't find the largest, you just might have to reduce it twice. Alright, to write a fraction in simplest form, then, you write the prime factorization, reduce it, divide by all common factors, so there are no common factors left. So some more examples. 50 over 22. 2 goes into both 50 and 22. So you can reduce the 2's, and you're left with 2 goes into 50 25 times. 2 goes into 22 11 times. Remember, you don't have to write this middle step out if you don't want. Alright, this is letter D on your handout. 9 over 90. What goes into both 9 and 90? Well, there are many things. 3 and 9, probably. But you want to use the largest. So 9 goes into 9 one time, and 9 goes into 90 10 times. So the answer would be 1 over 10. Okay? Again, you could write it out using prime factorizations, reduce away the common ones, and you're left with just a 1 up here and 10 on the bottom. 35 over 75. We know that 5 goes into both, so you can reduce the 5's out. 5 goes into 35 7 times. 5 goes into 75 15 times. And that's letter E on your handout. Okay, so to write fractions in simplest form, figure out what factor they have in common and divide out that factor from each term. Alright, it does get a little harder. This is letter G. 7a cubed over 56a squared. Now we have letters and numbers. Variables and numbers. Okay, so first of all, I would start with the numbers. What goes into 7 and 56? Well, 7 goes into both. So you can reduce away a 7, and you'd be left with 7 goes into 7 one time, and 7 goes into 56 8 times. For the letters, write them out. A cubed is a times a times a. A squared is a times a. So 2 of the a's are going to cancel, along with that 7 that we just talked about. And we're going to be left with a over 8, or 1a over 8. Would be another way to write it. You don't have to include the 1. Again, because 7 goes into 7 one time, 7 goes into 56 8 times. This one has 3 a's, a times a times a. This one has 2, so 2 cross out, and you're left with an a in the numerator. If the a cubed was in the denominator and the a squared was on the numerator, then we'd be left with 1 over 8a, because there were more on the denominator. So you'll see one of those, a letter H, on your handout. So go ahead and try letter H. 6x squared over 60x cubed, and see what you get when you reduce that fraction. Okay, so far I have to do C and E and H for class. Okay, and the last part here is to determine if two fractions are the same. Are they equivalent? Is 3/9 the same thing as 2 over 6? One way to do this is to simplify both fractions. Okay, so to simplify 3/9, 3 goes into 3 once, 3 goes into 9 3 times, and you get 1/3. To simplify 2/6, 2 goes into 2 once, 2 goes into 6 3 times, and you get 1/3, and you'll see that the fractions are the same. They both reduce to 1/3. So one way is to reduce the two fractions. The other way, and this works better for harder fractions, is to check their cross products. Cross products means you multiply across. So 6 times 8 needs to be the same as 2 times 24 in order for these fractions to be the same. 6 times 8 is 48, and 2 times 24 is also 48, so they're equal. So therefore we know, since their cross products are equal, the fractions are equivalent. The fractions are the same. If you got different things, if you got 49 for this one and 40 for this one, then we would know the fractions are not the same. Okay? So is 2/5 the same thing as 4/11? If you multiply across, that would be 22. This one would be 20. So we know those are not the same fractions. They're not equivalent. So for number 3, why don't you try A and B? Is 6/15 the same thing as 34 over 85? And is 8 over 11 equal to or equivalent to 18 over 26? Okay, so that's it for that section. Make sure you do those 5 problems for class, along with those problems from section 4.1. And in class, we'll do this homework, and you can ask me any questions at that time.